Hey, how's it going everyone? It's Mr. Primmer here, and in this video I'm going to show you how to do Bohr diagrams. So what a Bohr diagram is, it's a diagram that shows the arrangement of the electrons in that particular atom. So let's start with a few examples. So here is boron, and this is the scientific kind of the standard notation of how it's written. So right here is the atomic mass, and right here is the atomic number. So remember, the atomic number is equal to the number of protons, so we're going to write that here. So we'll put 5p in the middle, and this inner circle is representing the nucleus of the atom. So if you remember, the nucleus of an atom has protons and also neutrons. And to find the number of neutrons, you take the atomic mass and subtract it from the atomic number. So therefore we would have 6 neutrons. Okay, so that's the start of the Bohr diagram. Is it okay so far? Alright, so from there, now we need to add the electrons, but we actually draw the electrons. So how many electrons will a neutral atom of boron have? So it will have the same number as the number of protons. So it will have 5 electrons. So we're going to start by adding 2 electrons right up here. So 1 and 2. Oh, it kind of looks like a weird smiley face with 2 eyes. So that's how you can remember how to start a Bohr diagram. But the thing with this first energy shell, and we call these different circles around it energy shells, is that the first one can only hold 2 electrons. So now we still need to have 3 more electrons, because right now we only have 2. So then we're going to start adding them to the circle around here. So 1, but instead of lumping them together in pairs of 2, we're going to put them by themselves, spread out around the, if I can do this here, let's see. Okay, spread it around the energy shell. Okay, so now we have 1, 2, 3, 4, 5 electrons. So we're okay. And we wouldn't actually need to draw this circle up here. Okay, so this would be the Bohr Rutherford diagram for boron. So we'll give us a big check mark there. Okay, now let's go and do some other examples. So neon. Okay. So where we start with the number of protons in it. So neon would have 10 protons. And because the atomic mass is 20, we take 20, subtract 10, and we'd also have 10 neutrons. Sweet. Now we're going to start adding them. Remember, we make the kind of the weird smiley face with the 2 eyeballs up here. So 1 here and 1 here. Okay. And now how many more electrons do we need? We need 8. So we're going to add them to the second energy shell. So 1, 2, and because there's 8 of them on the second energy shell, we put them into little partners. Whoa. Here we go. There's 1. Okay. And then 2 more over here. I don't know why my tablet keeps making these weird circle things. Come on, there we go. Okay. That was a little painful. Okay, so now we have 1, 2 on the first energy shell, and we have 8 on the second energy shell. And this is actually the maximum number of electrons you can have on the second energy shell. So if, let's say, we had an example that had 11 electrons, then we'd have to go up here again. Okay, so that is neon. Okay, let's do one more example just to see if you are okay with this. Okay, so we have chlorine. So chlorine will have 17 protons. And how many neutrons would it have? Neutrons, you take the atomic mass and you subtract the number of protons. So in this case, 35 minus 17 would be 18 neutrons. Okay, and now how many electrons would it have? So remember, it's the same as the number of protons, so it would have 17 electrons. So we'll start putting some here. Whoa. Let's try that again. Okay, so there's 2 electrons. And remember, now we have to go to the second energy shell. So here we go. Okay, so now we have 10 electrons altogether, so we need 7 more. So what we'll do is, when you don't have a total number of 8, you start by spreading them out. So now we have 4, but then you go around and start partnering them up again after you go around once. So therefore we'll stop right there. So we have 1 extra spot there. Okay, so that would be the Bohr Rutherford diagram for chlorine. In the middle, in the nucleus, it shows 17 protons, 18 neutrons. And then in these different energy shells, it shows the arrangement of the electrons. So in the first energy shell, we have 2. In the second, we have 8. And in the third, we have 7. And that equals 17. And the maximum number of electrons you could have in the second one is also 8. So if we had more than that, we'd have to start a new energy shell. Okay, so hopefully that was helpful, and maybe I'll see you again later.